So let me know what you need help with. Right now, everybody that's here, type your name in the response pod. If you're listening to the recording, write response pod and write your name so that I know that you heard me ask you to do that. Okay, so if your function looks like this and all the question says is what kind of conic section is it, then you're looking at only these two terms. These are the only two that are important. If A equals B, it's a circle every single time. If A is 0 and it's just got a y squared, or B is 0 and it's just got an x squared, it's a parabola every single time. If it's an ellipse, then they're not equal, but they're the same sign. So like A would be 2 and B would be negative 16. Okay? And these are on the handout. That's what the handout is, the stuff that's on the slide, so you can have that so you don't have to worry about writing it down unless you want to. And then in a hyperbola, the A and B are opposite. So the A will be a negative number or the B will be a negative number, but the other one will be positive. Any questions about the general way to tell if a conic section is what it is? Do y'all understand what I'm saying by A, B, and C, and D? And well, it's just A and B. It doesn't, all this other stuff doesn't matter. You don't even have to look at it. It doesn't matter how complicated it is. You're only looking at the coefficient of the x squared and the coefficient of the y squared. Everybody good? Yeah. Now, parabolas. It's been a while since we've done parabolas. I've really spread this unit out for y'all. So remember, the distance of the focus to the vertex and the distance of the vertex to the directrix is C. The book may have it as a P, but it's the same. And if it goes this way, this distance, let me maybe change this color. And, oop, not red. Yellow. And this distance are the same. So the distance from the focus to the directrix is the same distance, and it's the C value. The directrix is an equation of a x-axis. This directrix goes this way. It's a y equals number, y equals whatever, because it crosses the y-axis. Okay. The key to all the conic section problems is to draw a little picture. And when you draw a little picture, it all falls into place. And there's your formula. The x is the variable that is squared when it opens up or down. The y is the variable that's squared when it opens left or right. All right, any questions about the H is always with x. K is always with y. A lot of students here will call their vertex KH because they think the value here is the first part of the vertex. It's not. It's HK. So just kind of note that and remember that the x and the y and the k go together. So when you write this center, your ordered pair is still, oh wait, I gotta get a pencil, pencil. Your center is always HK, no matter what. Doing a specific problem yet? Everybody okay? Morgan, I see you have your hand raised, but I think that was from before, right? I wasn't trying to ignore you. Okay. Okay, cool. So that's parabolas, real quick and easy. And this picture and all this stuff is in the handout, so kind of make notes of what we're talking about. Circles is the easiest. Don't get circle problems wrong. They're a cinch. It's x minus 8. You hate circles, but they're easier, right, Valerie? And the reason I say circles are easy because there's not all the parts and pieces. You got a center and you got a radius, and that's all you got. There's nothing else. Exactly. Our radius is going to be 5. So be careful. The radius isn't 5 squared. The radius is 5. It's whatever number is squared. And it's okay, Morgan. You don't have to love circles. I don't love them either. I think they're kind of boring, but they're not hard. because there's not much to them. There's not a lot of pieces and parts. Yes, we'll do a circle as well. Absolutely. I just want to get through all the standard stuff. We'll do ellipse. We'll do a circle. We'll see what else you guys need help with. And the line of symmetry, don't get that wrong. All right, ellipses. The key thing to remember to know which way the ellipse open is which denominator is bigger. Tells you which way the ellipse opens. If the x has the bigger denominator, hold on a second, let me grab my little pencil. If the x has the bigger denominator, the ellipse opens this way. If the y has the bigger denominator, oops, well, let's pretend like that's an ellipse. That it opens this way. All right, so let's go through all of our, there's our lovely picture. This is in the handout, and here's our lovely formula. So the major axis is the longer one, so for this horizontal ellipse, it goes this way. For the vertical ellipse, it goes this way. Okay? No big deal. It's just longer. That's where the bigger, right? The bigger denominator. So since this goes this way, in that case, this is bigger. And that's what makes it longer on the y-axis because that's below the y variable. This one goes this way. The A is bigger. It's below the x. So that's how I can kind of keep track which way it goes. Okay? From the center, if you count this direction, that's A. If you count this direction, that's B. If the center is not 0, 0, it's still the same thing. From here to here is the B value, and from here to here is the A value. So it doesn't matter where the center is, whether it's 0, 0 or 2017, you can count over. So it's very good to have a graph with some graph paper. The foci points are always on the major axis. The major axis is the longer one. So an identity, or what would make it be that that would be a thing that we would need to use? What kind of questions are they going to be asking about or giving us if we were using that Pythagorean identity? Right. If you don't have B or C, or you need to know the length of something, that's where you're going to use the Pythagorean identity. This distance from here, the center to the focus, is C. Okay? The distance from the center to the vertice is A, and the distance from the center to the co-vertice, the shorter side, is B. So if they talk about the foci or want you to find the foci, you're looking for this because the distance from the center to the focus is the value of C. And that's why you need to use this sometimes, because sometimes you only know the focus and you're looking for the vertice. Or sometimes, so it just depends on the question, but that's kind of how it all goes together. I know we're just doing general stuff, and oh my gosh, it's almost 1:30. Okay, I got to hurry. We got one more kind of to look over, and then we're going to do some practice problems. All right, any questions about the have a plus in it, right? And it has to be equal to 1. Don't forget the equals to 1 when you're writing equations of ellipses. All right, cool. All right, one more, and then we'll do some practice problems. Hyperbolas. The most important thing in hyperbolas is which variable is first. Which variable is first? Hey, Brianna, good to see you. You're going to want to watch the beginning of the session to get the beginning part, okay? All right, so hyperbolas is which is first. So let's look at what the variables or what the equations are. All right, so here's our equations. It opens on the y-axis here and here. So that's okay. So if the variable is first, that's the indicator of which way the hyperbola opens. And if you don't remember that, it's hard to keep track of which formula is which. Remember, the center is at HK. Here, H is here. but over here, h is here. Remember, h and x always are together. So your center is hk. Even if it's not listed first, it's still the first part of the center. Okay? Type in the response pod. That's great, Mallory, because usually hyperbolas are the hardest. That's awesome. All right, in the response pod, type in what you think the Pythagorean relationship for hyperbolas is. And if you don't remember, it's okay. You can put I don't remember. If you're watching the recording, you need to add that to your hyperbola. Type what you think. I mean, y'all might be typing. It just takes a second. Type what you think the Pythagorean relationship, and that's okay if you don't remember. And you might not have gotten here yet. You've lost it. I know. Sometimes stuff gets lost in my head, too. All right, that's the center. So HK is the center. Oh, got a lot of people that don't know. It's okay. All right, did everybody respond? It's okay if you didn't respond correctly. You responded something, so that's good. Here is what it is. All right, it's easy. It's a squared plus b squared equals c squared. Pythagorean should always make you think a squared, b squared, c squared. The difference is ellipses always have a Pythagorean relationship have a minus. Right. So for hyperbolas, their Pythagorean relationship is the Pythagorean theorem. A squared plus b squared is c squared. So you were right. That's right. So it's trust yourself. Okay. So, and we're going to use that when we're working with the foci. And still and again, the foci, the c is the distance from the center to the focus, whether it's this what's the word for that? I can't remember. This axis is going to be b, and the distance from the center to the end of the vertice is b. Coterminal. Coterminal axis. I think that's what it is, coterminal. Okay. So a lot is the same. That's what makes it a little bit hard, because it's the same. They're always equal to 1. Has asymptotes. It's just b over a. For this side, and this one is a over b. So it's the first divided by the second one, or the second one divided by the first one. Okay, so that's kind of the general format of that. Okay, everybody should have known that, so it's okay. I don't think anybody did. That's bad. So y'all have a lot of studying to do. A lot of studying to do. All right, now let's do some practice problems. So somebody asked about ellipse. Somebody else asked about circles. So let's do a circle and ellipse problem. And let me get the right book out. And I didn't pick any because I wanted to make sure to use the All right, let's do this ellipse one first. Okay? Let's do an ellipse one first, and then just because I saw that before I saw a circle problem. All right, so here's the problem, and it's on page 667, just so you know. It's 4x squared. Let me make sure this is still going to minus x. Oh, wait, that's not an ellipse. Oh, wait. Hold on. Y. I'm copying part of one problem and part of another problem. That's never good. All right, 4x squared plus y squared. I'll get it straight here. Hold on. And I'm trying to use the whiteboard because it is process a little bit. Minus 16x minus 6y plus 9 equals 0. Now, I immediately, when I looked at that, knew it was an ellipse. because this had a coefficient of 4. This has a coefficient of 1. They're not the same. They're the same sign. I know it's an ellipse. That's important because if it says, give all the information about the conic section, and you don't know which conic section it is, it's going to be difficult. Okay, the chat pod got really little. Okay. To see if I can do something without making y'all too confused. I'm going to try to push 2 steps together because this board's really little and I'm going to run out of space. Is that okay? I've kind of put these together and factored out the 4. Oh, that's okay if that needed to be moved. I didn't care. I just thought that we got y squared.
I'm sorry. I thought that was a private chat box that I started.
Oh, well, that's okay. Well, if you did, I don't have my thing where I can see it. So you want to link me? I don't have it in presenter mode. That's it. Put it in presenter mode and it'll pop up. I took that out. Okay, so now we're ready to complete the square. Now you have to remember in conic sections, we have lots of times that we complete. I think that's why I took the presenter out because I had so many pods open. All right, so we're going to take the middle term and we're going to half it. So -4 halved. Freak out. That's no big deal. You can do that. And then you're going to square it. So half of -4 is -2. -2 squared. That you're going to add right here. Now, hopefully everybody remembers how to do that from when you did quadratics last semester. Okay. That's good to know. You want to open up?
Yeah, that was the wrong one, wasn't it?
Open a. I gotcha. Why don't you open a do you know how to do a breakout room?
Yeah. Yeah, I know how to get to the breakout room, but does that not mess everybody else up? No, it doesn't. Okay.
It doesn't. Just take her in a breakout room. Okay. This 4. I know a couple people already have a green check. Give me an applause if you're good with this 4. You know where it comes from. You understand. You've done completing the square before. Okay, a couple people don't. Oh, Amanda, you okay? All right, good. All right, AJ, what are you completing the square? Have you done this before? You remember how to do it? Right, we're not quite done. Exactly, we're not quite done. Okay, Brianna. Here, but we have to be careful. And this is why I didn't add it to both sides yet. I want to make sure everybody knew where that came from. We didn't really add 4 here. We really added 4 from here times 4 because everything in the parentheses gets multiplied by this number out here. So 4 times 4 is 16. So what we're going to add on the other side isn't going to be 4. It's actually going to be 16. Okay, it takes practice, right? So we're really going to add 16 over here. All right, and then we have to complete the square for the y. So we get an opportunity to try again. So let's do it for the y. Not blue. Let's do like a because when I added 4 here, it was really 4 times 4 because it's in the parentheses. So what I added right here was really 4. I mean 4 times 4. So what I add over here has to be 4 times 4. Does that make sense? And the reason I had to do that is you can't complete the square unless you have a 1 for the square term. Okay, cool. Right. Now this one we won't have that problem because we didn't factor anything out. So we're going to take our middle term, half it, square it, all right, everybody real quick, in the response pod, put a 9. Everybody put a 9. If you're watching the recording and you're taking notes in your response pod part of your notes, you should have a 9. Super. How easy was that? See, easy, easy. All right, so we're going to add 9 here. I know it's kind of getting squished up, isn't it? And that means we're going to add 9 over here. Uh-oh.
I just came back.
Oh, gotcha. Okay, add 9 here. All right. Actually, let me do this. I'm going to scooch this over. I'm going to scooch. I'll try to make this whiteboard a little bit bigger. Let's see if I can. See, that thing just says questions. Oh, no, it doesn't make, I mean, it makes it bigger, but it doesn't give me more space because I've already written all over it. Okay, well, now it's giant. Maybe it'll write nicer. Okay, so let me get rid just where we found our 9. And now we can complete the square. The whole point of doing that is so that this is a perfect square trinomial. It's always going to be x. Oh, that's good. X, then the half part. Half of negative 4 was negative 2. Negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative. Remember, it's always going to be the variable, then the half part. Then we're going to add up 9, 16, and negative 9, which just
Miss
happens
Long?
to be 16. Okay, I just
I'm sorry.
added these.
Do you want me to let Kayla in? Do you see her?
Yeah. Yeah. Uh-huh. Hey, Kayla. We're working on conic section review, and then we'll start at the 2 o'clock session for your regular class. So you're welcome to stay if you're still working on conic sections. You liked it better, Mel, because it's bigger? Okay, but I have to just, it feels so slow. And it is because it's like almost not a 140 and I'm not even done with this first problem. Okay, so now, does this look like an ellipse? (16) plus 9. I just added these numbers together. They just happen to be the 16. Yeah, because the negative 9 and the positive 9 canceled out. Cool. Okay, so we're just, after you kind of write them down, when you write this problem and you're factoring these, you're just adding those up and you're just getting a number. Now, ellipses equal what? What do they normally equal? They normally equal 1. This doesn't equal 1. We're almost in standard form, but not quite. So what I'm going to do is divide each term by 16 so I can get a 1 there. I'm going to divide this by 16. And I'm going to divide this guy by 16. Because I can do anything as long as I do it to each term. Now this cancels. In our standard form, we've got x minus 2 squared over 4 plus y minus 3 squared over 16 equals 1. Now remember, in ellipses, which is bigger denominator tells us which way this thing opens. Put in the response pod, does it open horizontally, like this? Look at your denominators and type in the response pod, horizontal or vertical? Which way is it longer? Good, Amanda. Good, Mallory. Good, 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 good. One's bigger, so it's going to open on that. Right, Delaney? Right, AJ? Good. Okay, so you see how it works is this is bigger, so it opens on the y-axis, so it's going to be this way. It's going to Now, you're doing this on graph paper because graph paper is going to make your life happy. And in the file pod, I have graph paper, and I'll move all the, actually, let me move this now so you can see it. There's a chat pod, a paper right here. You can look at that, grab that graph paper and have it so you can just print it out. So we're going to put our center of this thing is positive 2. That's our center. And underneath the y, the value here is a because it's 4 squared. So I'm going to go up 4 units. I'm going to go down 4 units. And that gives me my vertices. And if you're on graph paper, you can just count and know the ordered pair of your vertices. This one's going to be 2, negative 2. And I found that because if I had graph paper, I would just count that. It would be 1, 2, 1. So 2, 7 is that vertice. Done. Now I'm going to go left and right 2 because remember this is like 2 squared and it's under the x. So that means from the center I'm going to go out 2 and I'm going to go out this way 2. So that puts this covertice at 4, 3, just counting. And it puts this covertice at 3, I'll just okay, 0, 3. And now we're just going to connect the vertices and the covertices, and we have a handy dandy ellipse. That's okay, Kayla. Have you finished Unit 3 with conics yet? And if you haven't, this is a good review. If you have, you can just come back in a little bit. It doesn't matter. Or you could just stay. Whatever. Okay. So there we go. Now, the only thing we have left to do is find the foci. Any questions about the vertices? Before we get to the foci, because the foci is the last thing we got to find. And then we'll have time for a circle question. Excuse me. Okay, great. So the foci are on the major axis. The major axis is the longer one. So whatever color I just picked, it's going to be somewhere here and somewhere down here. And I got to figure out the distance from the center to it, and that is going to be the value of c. So remember, we're going to use our Pythagorean relationship, a squared to the focus point. So a squared is 16, b squared is 4, 16 minus 4 is 12, and take the square root of both sides. I know I did that in a whole bunch of in a very few steps, but I'm running out of space. Any questions about how I did C? I know I did it like all squished together and skipped a whole bunch of steps, and I don't mind reviewing over where they came from. And that's going to be about 3.5, and I'll put a little squish. Square roots of 3. You want to pull the perfect square out. And probably any book work you do, the answer is going to be 2 square roots of 3. All right, any questions how I did that where I plugged in? Green checks down the row. Everybody good? I know y'all are writing, so when you get done writing, give me a green check and I'll know that you're ready to go on. And I'll show you how to come up with those ordered pairs. I don't want to, I know when you're writing and talking and listening and everything all at the same time. All right, wait for Donovan. And Kayla's just kind of hanging out, which is cool. Plus a little bit more, and that little bit more is 2 square roots of 3. So our foci ordered pairs will be 2 and 3 plus or minus 2 square roots of 3. Because it starts at the center and goes up 2 square roots of 3 and goes down 2 square roots of 3. So it actually would be like down in here. Our other focus. So there's our focus points. So we've got our vertices here and here. I know that's very squished in there. There's our other vertice, kind of hidden in that mess. And our co-vertices are here and here. And that's all you need to do for an ellipse. Co-vertices, vertices. Will you just email me, webmail me, and remind me to post it to the Algebra 2B class as well, and I'll do it in both places. But if somebody doesn't remind me, I know I'll forget. Because by the time I'm done at 4 o'clock, my brains are like mashed potatoes. I can't remember anything. So if you'll just webmail me and remind me, hey, Miss Long, can you send the 1 o'clock, post the 1 o'clock recording to Algebra 2B? And then that'll remind me that I was going to do that. And that'll help because a lot of students, when they go back to do the remediation from Unit 3, that'll help. And it will also help for anybody that's finishing up that wasn't able to come at this time. No problem. Thank you for reminding me because I wouldn't have thought of that. All right, that was a lot of information crammed on the be just like what we just did, so I don't want to necessarily do that again. Or one where they give, let me see, what kind of circle problem? What do y'all want to do? Circles. Think circles. What did you do when you did circles like a long time ago? For some reason, it feels like a long time ago to me. Hold on a minute. I'm flipping back to them. Just a second. Circles. Let's see. What were you given to do with circles? You were given, find the all right. All right. Let me get rid of all this.
I'm sorry, I'm sorry, Miss Long. I have to go. I have an emergency I have to take care of real quick. I'm sorry.
Yeah.
Thanks. Bye.
All right, so let's do a circle problem where they give the equation and you have to do the graph. Cool. Circles, but you know what? Circles are really no big deal. Like, for instance, how about this one? X plus 3. She kind of scared me too. I was like, whoa. X plus 3 squared. Miss Claster's awesome. Plus, oops, y minus 9 squared equals 49. Yeah. All right. So here's our problem, and this is a minus. So first we got to find the center, HK. It's just like all the other conic sections. H is with the X, K is with the Y. So that's our center. Parentheses aren't going. And what's our radius going to be? Remember, it's x minus h squared plus y minus k squared equals r squared. Right, so our radius is going to be 7. Because we could write that as 7 squared, right? Oh, let's. When we go to graph it on your lovely graph paper that I know that you have that looks beautiful and nice and wonderful, unlike my ugly, I can't figure out how to get a graph on this whiteboard. I've tried. I tried doing it all morning and it wouldn't work, so I'm just having to sketch it. So you're going to use graph paper because it'll be nicer. Seven means we're going to go up 7, this way 7, 7, 7. 7 in every direction gives us this circle. Now y'all know my circle is going to be lopsided as the day is long. Let's see, I'm trying to make it not awful, but it's going to be pretty awful. Well, I don't know. Well, I may be speaking too quick. That's not too terrible. That's not too terrible, but it's pretty bad. So, squished up egg or something. Yeah. But it's, compared to some of the circles I've done, it's not too bad. So to come up with the ordered pairs here is not too bad because if you're on graph paper, you're just counting, right? Let's see, 7. What would this be? 4, 9 on your graph paper. Is that 4, 9? I think that should be 4, 9. This one should be 7. No, -3. -3. And this one should be 7, 8, 9, 10, 10, -10, 7, -9, -10, 9. I'm just giving you the ordered pairs of where these should be on your pretty graph paper that's not all misconjugulated and ridiculous looking. Uh-oh. That's not what I wanted to do. And on your graph paper looks right, so that's why I'm giving you these ordered pairs. 7. So this will be -10, 9. So you know that it's right. And this one would be -3, 2? No, 7. Yeah, 2. So that way you know that your graph is right. And there's your graph. Dun, da, da. So all you have for center is circle and radius. That's why I kind of like circles, because there's not 100 different parts and pieces, but why I kind of don't dots. That's it. Yep. That's, I mean, there's not a ton of work with circles. It's a center, it's a radius. That's it. There's nothing else. There's no other formula. There's nothing else they can ask you. There you go. Well, that's good. Yeah, those circles are nice because they're not hard, but they're kind of boring because there's not a lot to them. But it's okay if you don't love them. It's all right. Now, here's the thing to remember. What if, this is a what if, what if this was a minus? What would this graph look like? Would it be a circle still? It's okay. You don't have to love it. But when it makes sense and you feel like you can do it, it's not as terrible. That's right. No, it would not be a circle. I mean, I don't have a minus. Ellipses do have a plus. What is the only one that's got a minus between the two squared parts? A hyperbola, that's right. If this was a minus, it would be a hyperbola, and then we would divide each side by 49, so we would get our 1 over. last lesson, the review lesson, they started transforming them off of the origin. Like, whoa, that should have been several lessons. And they just pack that in. And sometimes students kind of skip through that review lesson. This one is really important that you do those practice problems in the review lesson, because that is the only lesson where it's off of the origin. And it makes it a little bit harder. And I can promise you the test questions are not all centered at the origin. So you need to do those practice problems. It's really, really important. Which one is the one that you feel the weakest about? All right, do this in the chat, in the Voti pod. Hold on a second. Let me clear everybody's up. Clear status. All right, give me a green check. Let me finish telling you before you do it. Give me a green check if you want to do a parabola problem. Give me a red X if you want to do a hyperbola problem. We'll just vote. And I could do a voting pod, but I don't have time to open it. That'd take me 3 minutes. All right. All right. What about you, AJ? Kayla's just hanging out. All right. All right. The voters win. We'll do hyperbola. If you need parabola help, you can always go back. And let me tell you which week I did hyperbola. You need to go back and review that live lesson session. Feel free to do that. So circles and parabolas I did on the 19th. Ellipses on the 26th. Hyperbolas last week on the 5th. And today is the review. Okay, so I've stretched this out for a whole month to give you guys lots of time to practice. All right, let's do a hyperbola problem. All right, I'm just going to let Sarah in. All right, hey, Sarah, we're not quite done yet, but I went ahead and let you in. We're doing one more review hyperbola practice, and then we'll get started with your class. So if you haven't done conic sections, you might. That already. And we're going to find all the pieces and parts because for time reasons. Here's one. I don't want that one. I want this one. Number 14 is y squared over 81. Oh, that one's centered at the origin. I want one not centered at the origin. Hold on a second. Let me flip ahead a little bit. No. Ah! All right, hyperbola, not at the origin. Where is one? Right there. Oh, that one's pretty wimpy. Right there. All right, number 13. There we go. That's a good one. All right, so y minus 4 squared. All right, one more question while I'm writing this in the chat, in the response pod. Come up with a question. What are you going to do over spring break? Put that in the response pod while I'm writing this question down. Woohoo, Donovan! Wish I was going to Mexico. I'm probably going to clean my house. How exciting is that? Hang out, that's good. My kids have spring break the next week, so I'll be at home. But I'll be at home with the house quiet and don't have to work. I'm kind of excited since my kids have spring break after me. Ours just don't align. Okay, so here's our problem. We know it's a hyperbola because it's in the form of a hyperbola. This is a minus here, and that's the only way we're ever going to get a hyperbola. It equals 1. It's a hyperbola. All right, so now, what is the center of this hyperbola? Anybody want to type that in the chat pod? The center. And on your nice, neat graph paper, you're going to sketch this so it'll be easier to see. So what's our center? Hey, Ashley, we'll get started with your class in just a few minutes. I'm just wrapping up with the class I'm with, so just hang tight. The center right here. We've got, I think this is a 3. It does look like a 2. I'm sorry. This is a 3. But remember, the H is over here, and the K is with the Y, so be careful. X minus H, Y minus K. Nope, the center here, H, K. Careful. There you go, Amanda's got it. 3, 4. X minus H, H is 3. Y minus K, K is 4. You see the difference? So be really careful. So our center here is 3, 4. And we're going to base everything else on that. Okay, so we're going to sketch our little graph. You're going to do it on graph paper, so it's going to be nice and neat. This is 3. We'll call this 4. And there's our center. Now, remember, this is like 2 squared, and this one's like 3 squared. So since under the X is a 2, I'm going to go 2 units this way, and I'm going to go 2 units this way. And those are going to be the co-vertices because it's second in my equation. Okay, so since this is 2 under the X, that's how I know I'm going left and right. How much am I going to go up and down for the vertices? And I'm doing up and down because that's what's first. The Y is first. So I'm going to go up how much ever's in the denominator and down how much ever's in the denominator. Oh, it's 2 o'clock. We'll be done in just a second, guys, I promise. So we're going to go down 3 and we're going to go up 3. And then on your graph paper, you can count what those ordered pairs are. There's your vertice, there's your vertice. Now I know since the Y is first, this thing opens this direction because Y is first. If it was an ellipse, I'd just connect the dots. And to find out the focus point, I'm going to use a squared minus b squared, sorry, just kidding, plus b squared equals c squared. So I get 4 plus 9, c squared, c squared. So c is the square root of 13. So it's going to be here for a focus and here for a focus. All right. That was really fast, and I know I didn't do a lot of the calculations. So your goal is to practice that and let me know if you have questions that I can answer. That was a lot in a very short amount of time. But it's not the first time we've done it. So there's lots of opportunities and places that you can go to look for extra help, and then you can communicate with me if you need anything. Okay? All right, it is 2:02, so we're running a smidge late. I'm going to let you guys go. I'm going to turn off the recording. Oh, wait. Before I turn off the recording, before you use the watching the, there we go. No live lesson next week. Don't forget. We're going to be at testing. All of us, whoever's taking the test is going to be at testing. And if you're watching the recording, make sure that you include those questions that I asked for in the response pod or the Q&A pod. Okay, make sure those are in your notes. All right, bye, guys. See you later. Let me know if there's anything I can do to help as you're working through the content. And those of you that are here for Algebra 2B, hang tight. We'll get started in just a minute. All right. Let's let everybody in. There's everybody. All right. Delaney, you can go ahead and go. All right, who else is here from the last session? Is everybody else supposed to be here? Monty, Real, Camille, Austin, Ashley. Okay, cool. All right, let me, oh, I